Okay, we are live, guys. This is episode number 3 of a physics of Bitcoin. I have here my co-host Stephen Perrenot. We are both, for the people that don't know us, we are both astrophysicists that like Bitcoin and have studied Bitcoin for several years. We are work under this idea of a power law that is supposed to be our main understanding about Bitcoin. But we are exploring different topics that relate physics and Bitcoin because physics has been used for many years now in trying to understand how humans behave together, and Bitcoin is and Stephen will explain some of these things. It's a network, so network is one of the things that physicists study. And so even if for many people seems strange when people, and we are not talking about the individual at this point, right? So we're not saying something against the free will, for example. But in general, when people work together, they do become like a little bit like particles, so it makes sense to try to understand it with the tools that physics develop over the years to study different systems, from simple one to complex one. And so this is our approach, and we have a particular angle in trying to understand Bitcoin that maybe is not found somewhere else. Do you want to add anything else, Stephen, to this idea? We cannot hear you. At least I cannot hear you. Make sure your microphone is on. You are on from my side. I can try to turn you on and off. Try now. No. I think it's something from your side.
Must
okay,
be.
Try now. Yeah,
How about now?
perfect.
Yeah. Okay.
Now it's okay. Okay.
Yeah. I don't know. The light went red on my microphone. Now it's green. All right. There's some really interesting background to how populations behave and in social networks. There are some historical studies. Peter Turchin, professor emeritus at the University of Connecticut, has really an approach for history that he calls cleodynamics. I don't know if you've ever run across that.
No. Do you have a
really?
we have a chat. If you have any
Yeah.
reference or any link, you can always
I'll
write in the
mention
chat.
2 books. Yeah, I'll show 2 books. Just a moment.
Okay, fantastic.
This is The Rise and Fall of Empires is the subtitle. The title is War and Peace and War.
Fantastic.
He's ethnically Russian, but he's been in the U.S. forever and was a professor at UConn. And his background.
Tell me again the title. I will try to find it and put it in the chat. Show me again.
I will.
Yeah, you can write. You can write it in the chat. You should.
War and Peace and War. Peter Turchin. There we go. And he studied many empires. He's got a background in biology and population genetics, which is not so very distant from what Jeffrey West ended up studying as he got into the scale. But he then went in the direction of history and studying many empires and collective effects in empires and what makes empires, finally fail and so forth. So I'll recommend that. And it also goes back to Asimov's work in the Foundation series and the Foundation trilogy, right?
Yeah, psychohistory or whatever. Yeah,
psychohistory. So these collective effects do happen with human populations. Everybody knows about what happens with mobs and the wisdom of crowds. And we see over and over again in stock markets, we see crowding and herding behavior, right? particularly at turning points and when you have exponential rises and busts. And that's part of what's behind the log periodic power law that Didier Sornet investigated so thoroughly, and that you now are working with, Giovanni, quite a bit. And I've worked with it a little bit as well. So that's just a little commentary on that. And now I want to show our brief agenda for today, and then we'll see what else comes up. So let me share screen. Window. Okay. And
I'm testing different windows.
Can you see that?
Wait a second. No.
It's not showing. It's grayed out on the sidebar.
Yeah, let me maybe.
If you can open permission for that.
Yeah. I'm still learning how to do this thing. Let me see. Oh, yeah, I see that. Okay. Yep.
Okay, now we have that. Okay, so let me go to slide mode. So what we teed up to discuss today, and we may head in other directions, but we wanted to start out by talking about Bitcoin as a decentralized megalopolis. This develops from what we discussed a week ago in our last discussion, Physics of Bitcoin. And I just put up an article less than 24 hours ago, and it's my pinned tweet that summarizes essentially what I presented last week. Bitcoin is a decentralized megalopolis, and now also we want to show a chart that Giovanni has just developed. He's done an analysis of how Bitcoin is going to catch up to the world's largest cities collectively. The second topic is Bitcoin governance, and then also the foundational elements of ecosystem. And then I think we will revisit the latest on log periodic power law, and possibly latest thoughts on where MicroStrategy is.
Fantastic.
We'll see what else. We'll see what else comes up. I'm re-showing this slide from last week because
I'm going to buy that castle, and you can visit me.
Okay. Well, maybe you can check in, see how much that's going to go for. It's probably not for sale, but
there are a few castles in Italy that are cheap, you know.
This is quite large. This is a whole citadel.
Wow.
And it looks like it has a holy component to it, so it may be difficult. But in any case, this slide is from last week. I added a little bit of detail on it. So right now we're at 2 trillion. So that's the wealth that is stored in Bitcoin. And then one can think about the annual value increase, and you can refer to that as the GDP, right? The annual value that's being created by the Bitcoin ecosystem, and that's directly on the Bitcoin chain. That, that does not count the annual value that's being created by MicroStrategy, for example, or any profits that miners are making. That would be additional. So the GDP is above 800 billion. And even though we know with the power law that the growth does slow slightly from one year to the next, the GDP itself will continue to grow quickly because of compounding effects. So if we're at 2 trillion, and let's say we're growing at 43% over the next year as the mean trend, that's something like 860 billion. And then the following year, it may decrease to about 41% as the trend growth, but that would be based on top of 2.9 trillion. And so you would generate more than 1 trillion of GDP in 2026 for just the core of the Bitcoin ecosystem. So if you look at that as a GDP and compare it to cities, there are only 6 cities today with a larger GDP: New York, Tokyo, LA, Seoul, Paris, and Chicago. Now, Giovanni has done an analysis looking at the wealth of cities. And so we're going to show that on the next slide, and maybe you can talk us through that, Giovanni.
So And wealth here means basically the infrastructure, the real estate, and so these numbers are actually much bigger. And so the idea of this graph is you see the name of the cities. So basically, I order them. I, I took this information, the 15 uh, wealthiest cities. So they are selected in terms of their wealth. wealth. And then I sorted them from the one that has least wealth to the one that has the largest wealth. And I started to add both the wealth and the population. So on the x-axis, you see what is called the cumulative. Basically, you are adding, right? So I started with the population of Paris, then I'm adding Frankfurt. Frankfurt, weirdly enough, I don't know, it's something that we should look it up. Why is such an outlier, right? It seems that
Banks,
for a
banks.
banks. Okay, so it has a lot of wealth
Mm.
relatively to the population, right? So there is like a jump, but it's okay because sometimes you have outliers like that, and then the next city and the next city and so on. So every time we go to the next city, we add basically both the wealth. We do a jump in wealth and we do a jump in population, right? And I was pretty surprised that they form a very nice sequence, right? And that sequence is a power law, because we are doing a graph where we take in the log of a wealth in $1 trillion. So these numbers are trillions that you're seeing, and the population in millions. So the log of both X and Y. And by now, our power law aficionados should know that every time you take the log of both sides and you see something that looks more or less like a straight line, it's a power law. So it means that there is a relationship between the wealth and the population that is proportional to some power. And this power, you can get it by measuring the slope, right? So you get the slope of this straight line. You see this straight line. I didn't draw it by hand. We use these mathematical tools that is called regression. One of the reasons we like these straight lines is because it's easier to do what is called linear regression than other type of regression. It's much easier to calculate a straight line math than something more complicated. So you draw when you calculate the straight line, the algorithm gives you two things, because this is what you need to draw a line. You need the y-intercept and you need the slope. The slope is much more important because it tells us something about the mechanism behind the phenomena that you study. And in this case, when you extract that value, it's something close to almost 1. So 0.8. It actually, it's a number that comes up in other power laws in cities, right, Stephen? That 1.1, close to that,
Yes.
right?
Yes. So Giovanni, can we just set the stage a little more here? That
Yeah.
This is a log chart, right? So we're showing both cumulative wealth in the case of cities and cumulative population in the case of cities.
Yes.
So it's the total up to the city that's labeled.
Correct.
And so, for example, we start with the population of Paris, 1 trillion wealth, 1 million. By the time we get to Mumbai, we're at a population of 3 million total of 3 cities and 3 trillion total of those 3 cities.
Mm-hmm.
And then we continue all the way up until we have 200 million of population and over 20 trillion of wealth. And that all forms a nice straight line in a log chart. And we do our linear regression in log space, and that tells this slope. Now, the Bitcoin chart is a slightly different technique. So this is a chart
Correct.
as a function of time.
Yeah, let me explain. So in that case, what I did, I tried to kind of compare it. I say, imagine that. So in one end, we have this super city, right? We are creating this virtual city that is a world city, even if they are separated. that is building up by simply adding them. Now, one could almost think that is also one big city that is growing over time or something, right? One can imagine that it started with the size of Paris, when it becomes bigger and bigger and bigger, right? And it follows this pattern. With Bitcoin, the growth, it's historical, right? So it took 15 years to do this growth. And the way I was able to draw the line is using the relationship between wealth, that is basically the market cap in this case. So when we talk about wealth, we are thinking about market cap, the market cap and the addresses. So addresses are a proxy for the population growth, right? And the way I went from addresses to people is basically saying, let's take a value that seems reasonable, because nobody knows. That is really the only place where this analysis is a little bit weak, or arbitrary, if you want. It's to set the number of people that that can be considered Bitcoiners now. And I use a 50 million number for the actual population of the current population. Do you agree with that number or no? Do you think it's too pessimistic?
That's the number that I see on Glassnode, and they're pretty good.
Yeah,
I think they say 52 million. So
52 million. So if you use 50 million, then that number allows you to calibrate this equation, because basically there is a relationship between the addresses and time. So this is a relationship between addresses and time. It's a cube. It turns out it's a power law, because almost everything important in Bitcoin is a power law. So if you look at the growth of addresses over time, is a power law with the cube of time. But now you need to go from addresses to people. So if you use this latest value to be 50 millions, you can now transform it from addresses to millions of people. And that is how to interpret these dots, right? So every dot will be millions of people calculated in this way using the growth of the addresses. It's an abstraction from the equation, this equation of the cube of time of growth. And then to go from addresses or people to wealth, we use basically the equation that also we observe between the growth of addresses and the price. And that equation is also a power law, and is a power law. It's kind of close to the Metcalfe law. Metcalfe law will be the square, right? So the number of participants, because we are thinking about a network where the people are the nodes. What are they called? The nodes. And Metcalfe says the value of a network is proportional to the square of the nodes. So if the people are the nodes, it should be proportional to the square of a population. But when you actually go and measure it, it's more like 1.75. And so I use this equation to go from population to wealth. And this is what the little dots and the dates, the corresponding dates, when we achieve these values show. And then you can extrapolate, you see at a certain point the dots and it's all projection to the future, right? So if you continue that straight line, because the beauty of power laws is that they are self-similar. So if it behave like a straight line, it will continue to behave like a straight line. And that is also one of the things that many people don't understand, because they say, why the past should be valid for the future? Well, this is why we call this system scale invariant, because scale invariant means that it's self-similar, right? So whatever mechanism was making Bitcoin behaving in this way, where it was a straight line in the past, will continue to be valid in the future. That is an hypothesis, right? We don't know if it is true, but it's a very strong, valid hypothesis. So if it continue to behave in this scale invariant way, we'll continue to follow that straight line. And if you extrapolate it all the way to 10 years from now, it's interesting. I don't know if it is just a coincidence, or maybe there is something more, but it's very interesting, because when we reach that population of 200 million, that is the sum of these 15 cities, then we will have a very similar wealth. It is about $23 trillion. So 200 million people adopting Bitcoin will be equivalent to 23 trillions. And this is supposed to happen 9 years from now. And then, of course, from that moment on, we are going to beat all these cities, right? We will have to add more city to actually get more wealth. But actually, you can see from the slope, Bitcoin is basically catching up very, very quickly over all these cities, because it's doing basically one way of thinking about this. Some of these cities like Paris or Mumbai, I'm sure they are like thousands of years old, right? They are very, very old cities. And so we are accumulating the wealth that was accumulated over thousands of years in only 15 years. This is how it shows you how crazy of a system Bitcoin is from a financial point of view, right? It's doing something that is almost science fiction. It's like crazy, like that you have a financial system that can grow so much and is supposed to grow even more in such a small amount of time, right? And then, of course, once it catches on, it will continue to go faster because the slope is much steeper than this cumulative growth of this wealthy city, right? So do you want to comment? Do you have something that you want to add to this description of this graph?
Well, just to show the significance of this, 23 or 24 trillion, which is the wealth in those 15 cities, that's comparable to 5% of the world's private wealth. That doesn't include government wealth and corporate wealth, but that's 5% of the globe's private wealth just in those 15 cities. And so part of that is because cities are wealthier than the countryside, right? Wealth tends to concentrate on cities. Well, wealth concentrates even more so in Bitcoin. And, on the trajectory that it's on, a year after 2034, it should be close to 30 trillion of wealth for Bitcoin. And then 5 years after that, it should be 90 trillion, maybe closing in on 100 trillion for Bitcoin's wealth. So we're talking about a very, very interesting, next 20 years, but particularly these next 10 years, we're going to see this continue to sustain.
Yeah.
We believe to be true because the power law has been so stable for most of Bitcoin's life and has been kind of locked in quite well, that we don't see a reason for this trend to change certainly in the next decade.
Very cool. Yeah, feel free to continue with your presentation or with your slides.
Well, again, this is one slide from me and then one slide from you. So you put up this nice triangle slide, and I thought just to kind of set the stage for that and to have you discuss the foundation of the Bitcoin ecosystem, I would put up first this governance triangle. Bitcoin has tripartite governance, just as we have in most constitutions. In the US Constitution, we have 3 branches of government, et cetera. And then you have the law that they all operate in the context of that. So for Bitcoin, the judicial portion, at the peak of the triangle, kind of the final decider typically is the judiciary, is the full nodes because they keep the ledger. They keep the triple entry ledger, which already is a 700-year breakthrough in ledger technology. And then, of course, the executive are the miners, and they're engaged in the proof of work that generates the ledger, that takes transactions and encodes them into the ledger. And then the full nodes accept them, review them, and then accept them and commit. And then The legislative side is the developers. And here are some of the characteristics of the developers. Of course, we know it's open source. But what's important here is that there is so much stability in the process. There's a structured proposal process with extensive peer review. It's decentralized decision-making, and they very much prioritize security and stability and engage in comprehensive testing. So what we have is a governance system that is decentralized in all phases. The full nodes are decentralized, the miners are decentralized, and the legislature side, the developers are decentralized. And it all builds around the code, which is the Bitcoin core code that implements the Nakamoto consensus. Any comments on that before we move on to
I like it a lot. I like it a lot. Yeah. I didn't know about these, but yeah, it looks very good. I like it.
Okay, let's move on to your triangle that you posted recently.
Yeah, it doesn't look like as good like yours graphically, but I can.
Well, they're kind of similar. You know, there's a mapping, right, between those.
Yeah.
Three.
I'm talking about the look. You know, yours looks easy to see. So this is going to be a centerpiece in this article that I'm writing, right? Because many times I'm trying. And by the way, you posted also an article, right? Maybe you can put it in the chat if you like, the link to your article. But I'm writing this article because there was, I thought if I was in a certain space, I don't remember which one, and people were discussing where the value of Bitcoin comes from, right? Because it's something that is always discussed. Where really Bitcoin gets its value. And, you know, people say there is no value. It's all speculation. It's just a bunch of people trying to basically sell Bitcoin to the next person, you know, like if it was some kind of pyramid scheme, you know. But I think it's really completely missing the incredible breakthrough that Bitcoin is. You just mentioned, right? It's like an innovation that needed 700 years to be introduced because we didn't have a technology, we didn't have the ability to do this even intellectually, right? Or in particular, the technology didn't exist. But you know, there are all kind of ideas on where the value comes from, and I never heard. And you know, there are bits and pieces, but I never saw anybody putting it together in a consistent picture that is foundational almost, and also, you know, tying it together with some of the things that we explore, like for example, this idea that there is a relationship between adoption and the value of a network. But stating that by itself, okay, how come that there is value in that is the square, for example, of adoption, where that comes from? By the way, that particular details of why the price discovery follows this power law is something that I'm still working on. I think I have some ideas, but I'm going to do some simulations to show why that is true, that works with Bitcoin and doesn't work with other assets. But this kind of is almost like an introduction to that. And the idea is that there are really three components, right? There is I will start with really what I think is the core. And it's not that people have not mentioned this before, you just mentioned it, but I think it should be the first thing, right? When people say, but where Bitcoin gets its value, why is a valuable thing? It's nothing, right? Because I think I now remember where what motivated me to write this article. It was this discussion between Fred and Peter Schiff, you know, Fred Krueger and Peter Schiff. I respect Fred, and I think he's a great speaker, but was a little bit disappointed by the performance because I think he's missed some of these core issues. And the first thing I would have told if I was going to talk with Peter Schiff. I don't know if he wants to have a debate with me, but it would be interesting. But maybe I'm not famous as Freddy is. And at a certain point, I think I'm going to make a virtual. I'm going to use ChatGPT to make a virtual Peter Schiff, and then I'm going to. I'm actually serious. I'm serious because he's basically saying the same thing, so it will be not difficult to make, like loading on ChatGPT all these talks. Maybe ChatGPT even knows who the guy is, and I'm going to have a virtual discussion with him with ChatGPT through, like if he was a Peter Schiff. But I will tell him, the first thing I will tell him, look, how much value would you give to this incredible technological innovation that is a ledger? So this where this blue dot is. It's the idea that it's really, and so for example, if Satoshi patent this thing, and it's controversial because maybe the value is in the fact that he didn't patent, because it's actually gives more value the fact that there is not a patent. But even if he just patented, it will have had a lot of value, maybe in the billions by itself, right? Because it's really this idea that you could have a perfect ledger that if you think about it, this is one of the way, and I will write all these things in the article, but let me see what you think about some of these ideas. We're basically almost brainstorming. Take gold, for example, right? That Peter Schiff likes so much. It's not that Bitcoin, it's a proxy to gold. It's the other way around. It's like gold as it's the poor man version of Bitcoin. It's the analog approximation to what the perfect monetary system should be. That is actually Bitcoin. And I'm saying this because gold was, in a certain sense, a ledger, right? Because if you don't have a digital way of tracking all the transactions like Bitcoin does in a perfect way, you will try to use some form of exchange where I give you a piece of something that is difficult to reproduce, difficult to to make a forgeries out of it, and this will be something that looks like gold because it's rare. So the rarity is not what gives value to gold. Is the other? It's a function. It's difficult to forge. The reason why the rarity is important for something like gold is because it's not easy to produce from nothing, right? It's not like shells. So shells in the beginning was an exchange. But by the way, do you know where the shells were valuable? Were not valuable on the beach. They were valuable on the mountains, where there were these people that were finding shells on the shores, and then we were going in places that were far away from the shells and showing these very interesting things that were beautiful, etc. And they added some value, and they kept track of the exchange because the next person could use these shells to do another transaction. So it was a very poor way of keeping track of transactions and creating a monetary system. But it was always an approximation until Bitcoin. Now with Bitcoin, because it's digital, but also all the technological aspects of it, the fact that it has all these other elements like the proof of work and so on that gives foundation. It's almost like this thing that I'm describing here is a pyramid, and one of these very stable structure, or maybe some kind of a stool with 3 legs, that 2 legs will not work. When you add the third one, now it works and it's solid and it's a strong foundation. You could add more, but 3 is the minimum that you need, and you need all these elements to make Bitcoin valuable. So by itself, the ledger will have an incredible value because for the first time, we can track all the different transactions in the history of this system and make sure that there is no error, that is perfect. It's a perfect, eternal, immutable, and it cannot be diluted in value because there is a fixed value of Bitcoin. Now that idea of a fixed value is something that is always debated, right? Is it necessary? It's fundamental. To me, it's fundamental, and it's something that maybe in the future we can explore more. Something happened to the slide and disappears, Stephen, for some reason.
Let me
Maybe you
go back to the screens.
Yeah, maybe you need to move a cursor on top or something. But my idea is this, right? That it reminds me, and then we can have episodes on that because it's such an interesting idea. It reminds me, right, as a physicist, that we have an example of this in nature. In nature, everything that is created is always created respecting conservation laws. So, for example, when a particle is created from energy, you always want to create with particles, right? So, in a pair. So, there is a particle that has a positive charge. So, because energy doesn't have any charge, it's zero charge. The product of a creation, because Einstein showed us, right? E equal mc squared. You can go from energy to matter. This is what that equation say, that there are two different ways of looking at the same thing. You can take matter and destroy it and produce energy, or you can use an enormous quantity of energy to create matter. And when you do it, you have to do it in such a way where there is a positive element and a negative element. Like, for example, if you create an electron, you have to have a positron. It has a similar characteristic but opposite, right? So basically they cancel each other. This happens exactly in the ledger because basically you can think every time money is moved, right? Bitcoin is moved from one place to another, there is a positive entry and a negative entry, and they two cancel each other. So the finiteness of a ledger is almost like a conservation principle. Do you agree on that? Does it look like a conservation of money principle?
Yes, and actually, what it is the first actual scientific and highly precise standard for monetary technology in the history of mankind.
Exactly. And everything else is simply a proxy. So everything else, shells, gold, whatever, was an attempt to come close to this, and it could not be done.
I want to show something, and
so if Peter Schiff say, what is the value? What is the value of gold when it's just an approximation of Bitcoin? Yeah. That will be the whatever gold is valuable. Bitcoin needs to be more valuable than gold because it can do better what gold does by only this element. And this is the first element, right? It's not even the other two that are kind of necessary to give even more value to Bitcoin. By itself, this element will be already more valuable than gold. But yeah, go ahead.
Okay, I want to share. I'm going to stop sharing, and then I want to share. I have three comments. One is about Aristotle, and that's the image I want to show in a second.
Yeah.
And the second one is about virtualization and information.
Mm-hmm.
And the third one is that money should have no other use. So on the first one, can we show that one?
Yep.
Okay. And let me make that bigger a little bit.
Looks good on my screen. Yeah.
So you've talked about gold. This is from an article I wrote a couple of years ago. Aristotle laid out 2.5 millennia ago the key attributes of money. And there are, he had 4: durability, portability, divisibility, and scarcity. Now we'll get into some semantics about scarcity, but it's really the limited supply. And then I've added a 5th one into this table, which I call fungibility. And this is my framework for arguing that shells and, cattle and yapstones were money 0.x, and that gold was money 1.0, fiat was money 2.0, and Bitcoin is monetary technology 3.0. So these are very distinct, different generations of money.
Right.
Gold, now, money should have no other use except as money. The ideal money should be, it's a standard, and it's an interface between other sources of value, and it allows you to exchange value from one type to another type, from one good to another, from one service to a good, from one service to another service. Money, a pure money, would have no other use. Cattle has other uses. Yapstones, not so much. They weren't bad. Shells had other uses. Decorative. Gold is decorative. It has industrial uses. I've had gold fillings in the past. So gold is imperfect from the standpoint of not being a pure form of money. And this is a very important point, and it'll get into an argument about proof of work in a moment, if I remember it. So let's look at the attributes of gold. Its durability is that it's been around for millennia. It lasts forever. Almost all the gold that was ever mined is still with us. It's just been refined and resorted and reassayed. It's portable, but only in small amounts. If you want to make it portable in larger amounts, you need guards. You need armored trucks. You need a warship that the French used to move gold from New York back to Paris in the 1960s. It's divisible to some degree, but it's a little trouble to divide it, right? You have to make coins of various sizes, and then you have to remelt and restamp a coin. Scarcity or supply, it increases about 2% per year. And then fungibility, it requires weighing and assaying, right? I'm not sure that this coin is pure or a counterfeit, or that this bar might be titanium. Now, gold was both private money and government money, and it ended up being more and more government money over time. And from a geographical standpoint, it was local, it was national, it was multinational.
And can I make a point here?
Yeah.
Because it's very interesting. So people confuse many times why gold scarcity, it's useful for gold. Again, I'm going to repeat it. I don't know if you agree on that. It's because being scarce made it difficult to be forged,
Right.
And it was very difficult to forge it, because even if you try to forge it, you had to, whatever you were forging needed to have a little bit of gold in it, because if you made it completely of something else, that didn't have a quality of gold, like being heavy, being shining, and so on, you could tell very quickly. So any forgery needed to be always a lot of gold and maybe a little bit less. So there was not an incredible incentive. Maybe you could make money, but because the punishment were so big in comparison with what you could make out of that, it was not something that was done on a big scale. That is where the rarity and the property of gold come into place. It was not because, it's rare and so has value. It served almost like a proxy of what Bitcoin is doing without being really scarce. That is my opinion. It is not scarce, but it's finite. It is another thing.
Right. It was easy to work in gold, and it was a little difficult to counterfeit. But people would shave the coins, right? And Newton was master of the mint, and one of the things that he did was implement the reeded edges to make it harder to shave the coins. And at that time, counterfeiting was punishable by death, and he sent people to their death. Okay, there's a very interesting book about that, by the way, whose title escapes me, but his time at the mint. The next category is fiat money, of course, and it's become partially virtualized, partially computerized. It's pretty portable, but locally very portable, but internationally it can take a few days to move money across borders, right? Because multiple banks and multiple humans get involved. If you send a wire, and they use correspondent banks, so it can take a few days. And in fact, final settlement can take a month. The divisibility is very high, but as we know, scarcity or limited supply is a real problem. Because the supply is set by committees, and it's also set by, there are many, many agents, because every time a commercial bank makes a loan, that increases the money supply. So it's not well controlled. Fungibility, fully true within national borders, but once you go outside of that, you have exchange risk and exchange fees to deal with. And it's all government money now. And of course, it has national and multinational geographies. Bitcoin is fully green in all aspects. It's eternal in principle. It's going to last for centuries. As long as we have computers, and as long as we have decentralized full nodes, the ledger is going to be there. It's extremely portable in both space and time. We send it across the globe in less than 1 hour in any amount. We can send $1 billion, and we can send it very cheaply. The divisibility is very high, 100 million sats. There's no reason why you couldn't have a fraction of a sat, right? That's just record keeping. You could certainly do that on a second layer. Scarcity, the fixed maximum, it's a finite supply, and we all know that. And it's fully fungible. It's also private and decentralized, and we believe this is an advantage. So, we're all collectively involved in this movement to kind of put money back in the hands of people. And the geography is global. So the final point, I touched on the money should have no other use, and Bitcoin has no other use. If you get to the proof of work aspect, a lot of people have said, wow, proof of work is useless. You're doing nothing. You're solving a useless problem. That's the whole point. If you were to say, okay, I'll take half the cycles on the supercomputer to generate Bitcoin, and I'll use half the cycles on those NVIDIA GPUs to solve a computational fluid dynamics problem, you've corrupted Bitcoin. You've taken away the purity of the whole process, which is to achieve consensus in a winner-take-all lottery within a 10-minute block, and to record those transactions. And it is that activity of taking energy and transmuting it through cryptography, which is the alchemy that creates Bitcoin.
Right. Now,
so
one thing one can argue that right now Bitcoin is not used much as money, but more like store of value. But one way of thinking about this, because physicists are also thinking about this, this is a way of thinking that is very physics-like. That is, it's basically a transition, right? We are moving. It's not a steady state situation. We are moving from one system to another. We are moving from this fiat system. We left behind the gold, because gold is rare, but it's not used anymore as money. And we are going from fiat to this new system. And the fact that there is a value associated with that the value is increasing, is because basically in this transition, all the value that was associated with fiat now is going to be slowly but steadily in Bitcoin. Slowly, okay, depends on your point of view. Actually, it's pretty fast if you're thinking that it's doing it in a few decades. So my idea is that actually, at a certain point, very big hyper-Bitcoinization, it will happen, and probably will happen in the next 20 years. So in this process that maybe it's going to take 30 years, 35 years in total, we are going from one system to another. So in physics, we will say that this is a non-equilibrium situation where in the meanwhile, you can actually, as basically you are becoming kind of an investor, a participant in this new system. And by taking the risk in being associated, in taking the first step in joining this new system, you are being also rewarded by the fact that the system is gaining value relatively to the fiat system. Is this a good way of thinking about this?
Yes, and there are multiple ways for that to happen. And we're in the, I mean, everybody knows about, you know, using Lightning and what you can do with certain stores and so forth. It's really a matter of social acceptance to when it becomes interesting for the you know, the shops and the vendors to jump on board. The underlying technology really is there, but it will develop, and more of the fintech, you know, tech industry will get involved in making that happen. But the other way that it can happen is through national currencies if they start to add, you know, Bitcoin. If some country, and it will probably happen with smaller countries first, you know, obviously we have El Salvador, but others are looking at it. It's easier for a smaller country to do it, to add it as part of their legal tender solution, or even to start backing their currency with some Bitcoin. Then people are starting to indirectly adopt it as a medium of exchange through that mechanism, that their currency that they're already familiar with and using will have some Bitcoin component to it. But I wanted to say that the vast historical scheme here is the virtualization of everything, which is, you know, we're living at a time when we see everything virtualized. You know, music, right, has been virtualized.
Right.
Why do I even own this, right? Why do I own this vinyl? Well, vinyl has a little different noise to it, which I appreciate. But music is virtualized, books are virtualized. We still like to hold books in our hands, but you know, we have at least that option to read it on our iPad and so forth. Everything is becoming more and more virtualized, and pretty rapidly. And now we have seen money virtualize into what it wants to be, which is representing energy and information.
Yeah.
And so it is created with energy, and it is what I call electrons to bits. It's electrons transformed into bits, but they're very special bits where we do maximum work, not minimum work, to create those bits, because we want them to be highly, highly secured. And so
it actually it's funny because all the people like Peter Schiff, right, that insist on the how much more valuable is something that is physical, right? Now a house, okay, right now I'm still physical because, by the way, you know, maybe you do not dare to this, but I'm a transhumanist, right? This is one of my interests, so I'm actually thinking ahead of a few decades or maybe even century, and humans eventually will be information, even our intelligence. I mean, I know it sounds scary to some people, but it will happen, you know, where almost everything we do will be digital, will be information. Okay, right now we have bodies, so okay, a house, you don't want to have to live in a digital house, right? Even if in a sense you do have an extension of you, like for example right now all this is virtual, all this is, you know, we can do this and talk with these people online because one component of us is a little bit virtual, right? Our information, our words, our thoughts are over there. We care about our X account, you know, because we are associated with that. There is value in digital things. In my opinion, the digital things are actually more valuable than physical things, because physical things can be corrupted, they can be lost, etc. This is why the internet is such an incredible thing, because you can find stuff, right? I can find some of my posts on Facebook that I wrote 12 years ago. You know, all that information is there. With Bitcoin, even more, because that virtual information will be there forever, right? It's until there is an internet, even more than post online that can, you know, can be lost because they decided not to keep. YouTube decided to delete all the posts from 10 years ago, right? With Bitcoin, that doesn't happen. It's actually a way of making digital information valid and non-dilutable and non-deletable forever. That is actually another innovation, something that you cannot find almost anywhere, right? Imagine if we had a YouTube. In fact, if anybody wanted to work on a digital project, on a coin project, and there was for some time a project like that. I don't know what happened to it, but making a YouTube on the blockchain, that will be the validity of keeping eternal record, basically, of all these creations, that people do. They can go from a very well done video to, their children. You will never lose it. It will be there forever. And if you have a third party that is in control of it, you don't never know. In fact, all your posts on X, one day, Elon Musk decides to delete everything up to a certain date, you will lose it. And say, I'm scared, for example, with my Kindle, because I'm having all these beautiful books that is almost an extension of my mind, and I'm buying them. What if Kindle decide not to honor that, the fact that you own these books, right? They could disappear. What if somebody created a Kindle on the blockchain, right? Different project, not Bitcoin. Bitcoin does this, virtualization of information with something that I think is more important than all these other things, that is transactions between people, right? This is where the value is, the fact that you have this, final transaction between two parties that are recorded on these, almost like, in the Eastern philosophy, we have the Akasha records, it's recorded in this virtual world where you can go back and say, yeah, this thing definitely happened, and it happened at this date, in this particular moment. And it's amazing. It's something that I think no other technology has done before Bitcoin came about. Do you want to say something on that or elaborate?
I have nothing to add to that.
Yeah.
That's good. No, I'm reading Kurzweil's latest book, actually, about, AI and the singularity. So, yeah.
Right.
So we've got a lot of comments like that in the chat as well.
But if you don't mind, if you go, did you complete the discussion of this table? Because it's a beautiful table.
I did. So do you want to move on to log periodic power law, perhaps?
If you don't mind, I want to conclude the other 2 points in that triad.
Oh, yes. Go back to that slide.
Elaborate the other one, and they can be quick, and because I'm writing the article anyway, where I will go more in depth.
Yeah, let's elaborate some more on this. Okay.
And we can go back to the article when it's done. But I wanted to conclude my thoughts about that. If you don't mind to bring it back.
Okay, it's there. I think it's in your shadow.
Okay, I will have to approve it. Wait, no, I don't. Okay, I know where it is. All right, this is okay. So the record, that we say is where the principal value is, will be not even possible to operate if it was not this proof of work, right? And the proof of work is amazing because, imagine you're writing this in somewhere else, right? Where it can be lost, it can be hacked, etc., right? The proof of work solves all these problems, right? It's just not, it's not worth it to do that, right? Because it will require so much energy, etc. And that is something that you elaborated, that the link between these two things, this operation that you are doing, that is, you are confirming that this important transaction of value, because if two people agree that this thing is valuable, right, and we are moving all this hard work and whatever, some people maybe stole that money, but it doesn't matter. I think the majority of people putting their assets that were somewhere else, they put it in the network of Bitcoin. So they are adding value to the system, and then they decided to transact, right? Because even when you buy Bitcoin, it seems that you are not trading, etc. You are trading because you are buying Bitcoin, right? And somebody needs to sell it to you. So it's a trade, and that trade it's confirmed, and now it's confirmed by the proof of work, and that also gives physicality to the system because there is a lot of energy associated with that, and it's not a useful thing. It's probably one of the most useful things that you can imagine. That you're saying, yes, this transaction really happened, and this record is going to be recorded forever. So it's a very valuable action, maybe one of the most valuable things that you can ever imagine that can happen in anything, because transactions between people is how the world works, right? Even when we transfer words and information and knowledge, it's a form of transaction. This transaction is a primordial one. It's based on some very general and abstract value, right? Whatever that value is, value is what is accepted between two parties. I give you something, you give me something, right? And this is recorded through the proof of work. So it's a fundamental piece that is necessary and is part of this triad, right? And then, this will not be very meaningful if it was only between two people, right? If two people, okay, great, it's arbitrary, but this becomes universal if there is a network and many more people, more and more people join in and validate this value that these two people decided to have between each other, right? I'm going to give you this Bitcoin, Steve, and you are going to give me $100,000. Well, these two crazy people doing this crazy transaction. If there are millions of people saying, yeah, that is the real value of Bitcoin, we decide. And now it's done. It's done by consensus. It's done by these small little transactions. And this is why it's important to recognize it as this large network that is made of many different layers, because it's all this interaction that happen at different level between individual, between banks, between institutions. And this is how you get the power law, by the way, because when you have all these things happening at different scales, this when you generate power laws. And that network that is growing in time, is growing in a scale invariance way, it's also a fundamental component of this triad. The stool will crash if you didn't have that component, will not be stable, because it kind of confirms it. You need a blockchain to verify and validate all these interactions. Some of these interactions don't happen on the blockchain, but they do affect the blockchain by giving basically, the growth of a network through the buying and selling of Bitcoin, the addresses, and that is sustained by these very physical, because these things, the network is physical because it's made by people. There is a virtual aspect of it that is through the media, the social media and so on. But, this is very abstract. The ledger, it's all digital. And so these three things connect Bitcoin to the physical world of people and social interactions, the physical world of energy through the proof of work. And so it's not just an abstraction when people say, oh, Bitcoin is all digital. No, it has a very strong physical component. It are the people and the machines, so it's and connecting people, machines, and this abstraction that is the ledger. But when you put it together, it's very physical and very real and very powerful. This is where the value of Bitcoin is, in this triad. That is the core of the value, and I think it's almost invaluable, right? So it's like it's limitless value. It can absorb literally, because this is what it's designed for. It's designed to represent all the value of human civilization, and it can do it. Eventually, it will do it. It will absorb it. Everything will be transferred there, even real estate contracts, everything will be there, and it's doing it. And we have 15 years, and that graph that we show in the beginning, the trajectory eventually will be the wealth of all the world, all the real estate in the world, all the wealth of the world.
It's better than a black hole. You know, as we know, black holes only absorb material in their neighborhoods, and they're very, very compact relative to their mass. And, you know, stellar class black holes are just absorbing from their binary companion. They're not really pulling in matter from anywhere else in the galaxy. And the black hole in the center of our galaxy, you know, it's not even 1% of 1% of the mass of the Milky Way. So this is much better than the black hole analogy.
It's a bad analogy when people say it's a black hole, because they don't realize a black hole. So, for example, if a black hole of one solar masses will appear in the place of the sun, right? You substitute, of course, we will not get light, etc. But it's not that the Earth will fall inside the black hole. It will be exactly if a size. In fact, I think you cannot. Yeah, let's say it's how you got a black hole of one solar masses will be problematic, right? Because you need usually you get a black hole when you go beyond the solar mass. 1.5, more than 1.45.
The minimum is about 3. It's about 3 solar masses. That's
3 solar masses. The smallest possible black hole. Because otherwise, you get neutron stars. You don't get. But let's say you could make one. It will not behave any way different than the sun. It will be exactly like one solar masses have a center of a solar system, and the Earth will continue to orbit exactly like it does right now. And the only place where you will feel the fact that you're dealing with a black hole if you are very, very close, where space-time doesn't behave anymore like it will be very, very much bent.
No, Gio. The other thing is we wouldn't have any light from the black hole.
Well, I premise that from the beginning. I say that. But try to explain. It's not that the black hole is absorbing stuff because it's a black hole. It doesn't. It's not like that. It behaves like a normal mass. If you are far away enough from the black hole, it's indistinguishable as a mass from any other mass, right? Is that correct?
Yeah, certainly. I mean, it's just, we can approximate the sun as a point mass. Now, we do the detailed calculations to correct for the fact that it has finite size and et cetera, et cetera. But basically, you could put a one solar mass. It would have to be, how you would make it would be primordially, and how it would get there is very problematic because you disrupt the solar system totally as it came in. But if you just put it there
magically,
our orbit would not change.
Yeah, exactly.
Our life would be over, but our orbit would not change.
Yeah, and so actually it's a bad analogy because Bitcoin, I like what you were where you were going. Bitcoin does attract. It's something different, right? There is something different. It's almost like it has harms. It goes and grabs stuff, right? It's not that things fall into Bitcoin. It does suck into it things. It's more like a tornado. Maybe a tornado is a better analogy, right? It's expanding, it's getting energy, and is becoming bigger, and is bringing stuff. But actually, even that is not a good analogy because it has some kind of ability in bringing in things that are not in direct contact with it. And it's doing it in this power law fashion. So it's unique. It's really a unique phenomena. You can try to make analogy. Physicists like to make analogies like this, but there is no one that comes to my mind immediately, right? And how is able to attract all these resources, all this financial energy. Maybe we need to think about it, But it's really unique in that fashion. I don't mind not to talk about the log periodic because we can keep it within 1 hour. We are already beyond the 1 hour, and we can revisit it. We have several other meetings where we can revisit the idea of a log periodic power law. I did several progress, and I have understood interesting things about the log periodic, but I think it's probably better to dedicate more time next time when we meet the next episode. I think this is a good place where we can end the episode. I think we cover a lot of interesting things. By the way, what are you? Oh, I see.
Check the questions.
Yeah. We can check the question. We can focus on that. And I think you should be able actually to highlight some question yourself, right? I think you have a full control. So if you see any question that you want to answer, please do. You have the ability to show them, right?
I'm just looking at Marty's comments right here about market cap to price correlation diverges and the value increases exponentially. I don't quite understand it. Saying it cannot reach 10 plus figures because of market cap.
Are you able to highlight it? Or I have to do on my side, I can click a button that says show. Are you able to do that?
I don't know how to highlight it.
Okay, maybe I am the only one that can do it. I'm still learning this system. Is this one?
Yeah, that one and the next one from Marty.
Okay, and then he's saying this. So saying he cannot reach 10 plus figures because of market cap is a misunderstanding of the scarcity of a set. You want to say something about these? Do you understand the nature of the question?
Look, I mean, all our evidence is that it does not behave as an exponential asset. You just put it on a log linear chart, with an exponential, you have a straight line. It doesn't fit that. You put it on a log chart, it is a straight line. That's a power law. Now, with a power law, it can reach 10 figures, I suppose. Look, the issue is what's the total wealth in the world and how much does that grow over time? And then how much Bitcoin do you need if you want to denominate all the total wealth in the world? Roughly, the total wealth in the world currently is 900 trillion. And that's what Saylor presents. And that includes not only private wealth, but government and corporate wealth. And as we know, the large components of that are real estate and bonds and equities, etc. Cash, of course. Now, all of that wealth can be denominated with a total M2 money supply global of just a little over $100 trillion, because people don't sell their house every year. They don't sell their business every year. These things have lifetimes of years or decades or longer. So you can support the entire global economy with about 100 trillion or so. And in fact, the global GDP is about that. It's a little over 100 trillion as well. So if Bitcoin gets to 100 trillion in real terms, it would be sufficient to support the entire global economy, as long as, and as that global economy grew, then Bitcoin's value would continue to grow at the same rate as the global economy. I mean, once it became the only form of money, once you had hyper Bitcoin, then it would be representing all wealth and all economic activity. And you actually wouldn't need to grow in nominal terms, because now prices would not increase. You would not have the inflation that you have now. So you might find that you would grow real wealth with productivity, but you would not have an inflation component. And then other people say, well, AI is going to drive our growth rate up to 10%. But historically, we've seen global wealth grow at something like 7%. Maybe AI will accelerate it to double that. Maybe it'll be 15%. We have to see. But Bitcoin has the ability to denominate all of that, even as it reaches 100, 200 trillion. And that means, 200 trillion, that's a price of what, 10 million?
Yeah. And I think in my idea, I'm writing eventually something on that. I think when that happens, that basically we reach the entire wealth of the world, is this when the large nations will pay attention. It's not that they are not paying attention, but it will be the equivalent, right? There is a reason why the ETFs were approved this year. In this vision, I don't know if you are like me, where I go power law all the way. My understanding of the significance of a power law is this: that every single event that happens in the history of Bitcoin, it's basically scaled up. the reason why an ETF could not have happened 5 years. And people will think, well, because there was no the right legislations, because well, but why there was not the right legislation? The right legislation came about, the interest from BlackRock came about because Bitcoin was a given size. 5 years
It has
ago,
to get to a certain size for BlackRock to be interested. It has to get to a larger size for the U.S. government to be interested in a strategic reserve.
Exactly. So BlackRock was interested because he had arrived to a point, being $1 trillion asset, where they say, you know what, maybe we should put, we couldn't destroy it. We tried to keep it down. We were not successful. If you cannot beat it, we need to join. Basically, this is what they said, right? More or less directly. And this was the right time for the ETF to happen. They could not have happened before, and probably they should not have happened later because it was the right time. And when these forces like the ETF, right, they have an incredible influence on politics, etc., get involved, and they want to get involved, they will make the legislation. They will make it. They will interact with the politicians. They will do all the things that are necessary to make it happen. And everything that happens in Bitcoin happens in that way. So when Bitcoin will be the entire wealth of the world, then this when the nations will say, okay, it's time to join. We cannot stop this thing. It's the right size, etc. And what that will mean, maybe we can dedicate some episodes in these science fiction scenarios. I don't even know how to reason and how to think. I'm trying, and I tried several times, but do you envision a world where the Bitcoin standard is the norm, is what every nation is going to do? Because once the United States, then I do agree on the game theory. I don't know if the right word, people use this word game theory because they heard about it, but I don't think it's the correct way of using the word game theory. But in mathematics means something very precise. But basically they mean once the United States does it, everybody else does it. So you have some understanding of what a world where hyper-Bitcoinization happens, could mean, what that could mean?
I don't know. I mean, it's very hard to look out 30 years, right? I think we will adhere to a power law in 30 years.
Yeah.
And I think the power law is good until hyper Bitcoin, essentially, because it's going to grow at rates, faster than the S&P 500. Right. Over that period. So it's going to continue to be the most attractive asset. And then, at some point it sort of becomes the only asset for savings and core investment. And so I would say that, there are various possibilities. One is that nations do start to back their currencies in part. If you wanted to fully back, you'd probably need at least 25 to 35% holdings relative to your money supply, right? Because you've got to be prepared to defend it. But it would depend on what other currencies would be doing. And as far as, I think AIs are going to be an accelerant because sats are the natural currency between AIs, between bots. They don't have credit cards. They don't have bank accounts.
Right, absolutely.
But they need to transact with each other, and sats are the way to go.
And again, it's something that all the gold bugs miss completely. They don't understand how incredible of an application this internet money is. Not an insult. It's actually an incredible thing that we do have the real internet money that is Bitcoin. And this AI can transact, can do operation between them. They can reward each other, maybe different agents, etc. It's an amazing thing. Now, the entire scarcity thing, we will have other episodes where we go deeper in the scarcity because I think it's an important discussion. I don't think it's semantics. There are real valuable idea and concepts behind this debate about is Bitcoin finite, is scarce, and maybe Stephen has a different approach, and it's good because it can be complementary. We don't have to agree on everything. But my strong, not opinion, but I arrived to this conclusion in a very well thought manner. It's not something that I do it ideologically. I really think that it's the wrong word, scarcity, to describe Bitcoin. It's finite, and it's something different. It's not semantics. It's an important distinction because it has logical consequences, and also in terms of how we present ourselves to the world, how people think about Bitcoin, etc. But we can have this discussion another time because it's not an easy discussion. We can go back. I think a scarcity is the wrong way. One of the things I can tell you, and I don't know if you tried, Stephen, in my models, I always try to, if I could, include this 21 million. Where does it belong in the equation, right? For example, I have an equation that describes adoption and then how adoption impacts the price. And anytime I try to introduce that 21 million, I don't know where to put it in the equation. I don't know, I don't have any place where I could introduce the 21 million and it will make a difference. The only place where I can introduce it is when I think about something like Gini coefficient, so the distribution of holding, etc. Then it plays a role, and it's an interesting role, but it never impacts my model of price. Right? If I had to make a model of price and I had to include the 21 million, I don't know where to put it in the equation. Did you ever thought about that? Did you ever, do you know of how a constraint like that could influence price? Because to me, that constraint doesn't appear anywhere. The fact that there are 21 million, at least directly, right? And we know, like physicists, to us, physicists have a particular, almost like a, how will you call it, a professional defect or whatever, that we want to transform everything into an equation, right? If you cannot write an equation for this thing, it's not really, it's almost like this phenomenon doesn't exist for a physicist's point of view, right? In the end, we do want, or an equation, or maybe an algorithm, right? It needs to be some kind of an algorithm. And I don't know where to put it in the equation, that 21 million.
I think one place it does appear is in the economics of the mining industry, who right now earn 98% of their income from minting coins and only 2% from fees. And that balance is going to change. And in fact, I'm going to relook at that. I wrote an article on that some time ago. I'm going to relook at the projection of, when they get to 50-50. And the transition, that may change some of the economics around the Bitcoin mining industry. We're already seeing it in flux because it is such a hyper competitive industry that they're looking for ways to better survive through Bitcoin winters. When the price goes back to the Z of -1 or the base of the power law, and they're not making money on an operating basis, and they're not covering their capital depreciation. They're starting to, really most of them have now committed to entering the AI hosting industry. And so they're building up sideline businesses with AI. And that's very interesting too, because, we feel that those are complementary. So there's some shift going on. And I think also the shift between minting and fee-based, could occur. And so I think that's one place where it can be relevant.
Mm-hmm. But still, that will be more about the reduction in rewards. Is this what you have in mind, the fact that they get a reduction?
Well, they're going to make money, but they're going to make money from fees, and they'll be able to make enough money because the price will be that much higher, right? So they can still keep fees low and still make plenty of money.
Right.
But
I'm talking about the scarcity, the fact of, what people mention as scarcity, the fact that there is a finite number of Bitcoin. I don't see how that influences the price that people pay for directly.
Well,
right?
it doesn't. It doesn't. I mean, we know that what matters is the supply availability on exchanges.
Right.
That matters, right? But the difference between today's and the additional 450 tomorrow, it doesn't matter. It's
Yeah.
negligible.
So we can have this discussion later about is scarcity, is finiteness, what is the role of finiteness. I'm writing this article, but we can bring it up in our next discussions, because it's an important.
I would just say, you're right about scarcity and that people use the word in a sloppy manner relative to the original definition, but it's just common language that people use the word to mean what it really means is cap supply, right?
Right.
So almost everywhere that they say scarcity, people mean cap supply, but they don't
They
write
do,
it.
and at the same time they don't, right? Because in many times in the language there is this idea of, for example, of a supply shock. I don't know where this supply shock comes from. Like I don't see any evidence of that in the data, but also this idea that because there are more and more participants, there is less Bitcoin available. And I don't agree on that. I think there is as much Bitcoin as you want, because the only way that the price can go up is that there are people that want to buy it. And for every buyer, there is a seller. So it makes absolutely no sense to say you're running out of Bitcoin, because if we run out of Bitcoin, then there will be no buyers, and the price will not go anywhere. In fact, probably will go down.
It's always available at a somewhat higher price.
Yeah, I mean, if somebody is willing to buy, then there is a seller that is selling, and basically, you cannot say that it's rarer than it was before. Now, and it simply change hands, right? But we can have this discussion and analyze it in a more logical fashion in another episode, right? Now, for example, what kind of dynamics can happen on the market that pushes the price up, besides the general idea that adoption is what brings the price up, but also on a daily basis, right? How these markets work, what makes the price go up to $5,000 per particular day or whatever. But we can have this discussion in an episode that is more focused on that. I'm looking for other questions and see.
There was a question on Ethereum. Ethereum, why doesn't it follow a power law? Well, in order to have a power law, you have to have proof of work. That's a minimum condition. And, that's the core component of the triangle, is that mining process and the proof of work with energy, basically you're encapsulating energy into Bitcoin through a cryptographic. So you think of the gold coin, it has milled edges. Well, here the cryptography is what's milling the edges, as you pour the energy into the coin and seal it in there cryptographically. You have to have that. And they abandoned it. Before the abandonment, they actually did weakly follow a power law. Not as clearly as Bitcoin, but there was some power law behavior in Ethereum until, 2 years ago when they fully abandoned.
Right. I'm looking for the question to highlight it, but basically somebody asked why. I
just answered that.
I was highlighting
power law. Ethereum was using proof of work earlier in its history. Did it follow a power law? To some degree, it did, but it wasn't as strong.
We did that, of course. It was one of the first things that we tested, right? If it were, and not just me, but Stephen and many other people. It's a very weak, in the sense that if you do all these statistical calculation, for example, the R square because it can always fit a power law through anything, right? This is what Plan B does, it fits power laws. And one day we should go and discuss S to F, it will be an interesting episode, but it tries to fit power laws where they don't belong. And you can always you can ask the computer, right, draw me a line through this thing, and then you will get a really bad result. With Ethereum, you get a very bad R square that is already an indication. I also have all these scale invariant type of tests that, again, we can have an episode about that, how can you try to show scale invariance without using regression? And it fails miserably. Ethereum fails this other type of test. But the logic behind that, beside what Stephen say, I will add also another thing, that is this network effect. Bitcoin has been the first network of this kind, and will be always unique, because once you create a network of this kind, is not, and this is another thing that Peter Schiff was saying, because it's one of the usual criticisms, why another network can come and people will jump ship, right? Like they practically, I was using Facebook when I came up in this world of a Bitcoin media and Bitcoin social world. I was mostly operating Facebook, and there was a lot of activity. It was one of a group that actually I help moderate, had 70,000 people in it, right? It was very, very active. I went there recently. It looks like a cemetery. Nobody's there. And so you will think, because most of us are here on X, right? And you will think that, that could happen with Bitcoin, that people can jump ship. It was, people were saying things like that with Facebook, like, oh, it will be very difficult to move on your picture or your post or your friend. But people eventually did it, right? If you have enough strong motivation. With Bitcoin, it's very different. And again, this could be another topic for another episode. It's very much, my analogy to that is very much when the cells decided to go from unicellular organism to us, right? A multicellular organism. They joined together, and their joining together was able to create this better organism, or a useful, more powerful, better organism that was able to find food and resources, survive different. That is what happened. But the value of a network, it's in the network itself. If you leave Facebook, yeah, okay, some of your posts, some of your pictures, but you also can migrate them in the next social network. With Bitcoin, you will lose all your value. The network will immediately lose its value. And even if, okay, the single individual maybe can do it, like, you lose air and things like that, the entire organism per se has all these mechanisms where that is not possible. It's very unlikely all the cells of my body decide, hey, let's leave Giovanni. We have enough of him. Let's go and be unicellular again, right? It's not going to happen. That doesn't happen with Bitcoin, because the system has mechanism, like, for example, the proof of work, all these things that basically is almost impossible for the system to collapse and break down, because the value it's in the system itself. So once you create a system like that, that is self-sustaining, self-supporting, has all these loops, it's extremely robust. And because the goal, remember, is to bring all the value of the world in one single system. Once a system happens, it's very difficult for another one to imitate what this first system does. It has an incredible advantage over anything else. And this is why, it's a fact, it's an observable fact, that the dominance of Bitcoin, if you calculate it in the funny way that they do, and I agree with Saylor, he says it's a ridiculous calculation when people say dominance is 51, 52%. It's fake, because they sum up all these fake coins that have market caps that are just a number on a paper, right? Like, I had a company that was worth $10 million. I never saw that $10 million. It was on paper. It was this Terranos. It was worth billions of dollars. And then, when they find out it was fake, right? That you know what I'm talking about, that company where was supposed to measure your everything from your blood with one single drop of blood, right? Would have been amazing. And it turned out to be fake. It was a scam. And then the company value went from billions of dollars to nothing within a very short amount of time, because these valuations are nothing. They are made up, right? So same thing with many of these coins. Are made up valuations. And so the dominance of Bitcoin, if one really went and looked for value, is probably 90% or 95%, right? There is only one. Everything else is trash, you know? And so if you had really to calculate based on real factual value, participation in the network, I mean, you know, okay, maybe there is some Ethereum conference somewhere. I don't know even where. How many people go there? For sure, not 20,000 people like they go to the Bitcoin conference. That is part of a network effect, right? The people like us at 8, 9 o'clock in the evening here, or, you know, whatever time is it, where are you? Are you listening to old guys for 1 hour talking about the physics of Bitcoin? Do you see anything else like that happening with NVIDIA or Tesla or any other coin, you know, other assets, right? Or even gold? No, you know, we are fanatics. We are crazy. We are, you know, we do this because it's network. It's this incredible thing that Bitcoin is, that goes beyond just being, when Peter Schiff
I'm
said,
not crazy. This is all rational to me. This is pure logic.
people from outside will think that we are crazy, right? Like what these guys are talking about, you know, is so absurd. But you know, what I'm trying to say is that you know, it's much bigger than us. This is when you know that you're dealing with a network, when the sum of a part is much bigger. You know, the whole is much bigger than the sum of the parts. That is the definition of a network, right? That there is a value in coming together. And this value, once is achieved with something like Bitcoin, that is trying to be one. It's like basically like a Highlander. You can have only one. You know, this is why Sailor is right. There is no second best. It cannot be second best. And people like some of the founders say this. Alfini is say, "Oh, I'm not worried about people copying." I don't remember the exact words. Maybe somebody can find the quote, but he has a very famous quote where he addresses this problem, and he says something very similar. If there is a copy, that copy, it's already a copy, and it's not valuable because the entire purpose of Bitcoin is to be unique, you know, and this is why once you create this system and it has this advantage, it's almost impossible to overcome that advantage. And it's not something that we are making up. The reality shows that is really the case. So this is why it's incredible there is a power law in Bitcoin, and also very cool that there is no any other power laws. It's the only power law that, in particular, a power law that really, one of the fundamental, and you can find it in paper, one of the fundamental requirements for a power law to be a power law is that spans many orders of magnitude. This way you know that you're really dealing with a power law. And Bitcoin spans 6 orders of magnitude if you use the data available. If you include the first transactions, actually it's 8 orders of magnitude. Right. It's 100 million, right? That is what it means. And it's incredible, you know. So yeah, everything else is not a power law. and it's meaningful. It means something, you know. Anyway, guys, I think we did again pretty good job in covering very interesting topics, and we can come back next week. So thank you to stay with us and follow these discussions, and we will come back.
Thank you, everyone.
Stephen. Bye.